going to cover Objective 34. We are going to solve problems involving permutations and combinations, okay? Before we begin, let's do a little bit of an activity, okay? I need 5 volunteers, okay? 1, 2, 3, 4, 5. Okay, sorry, I didn't make it all the way over here. All right, we can do 6. We'll do 6. 6 people in the back, right there in the corner. All right, so I would like for the class, I want to take a picture of these 6 people in a line. So you can't like put 2 in the front and 2 in the back and, you know, blah, blah, blah. I want them in a line, and I want to know how many different orders can I put them in to take a picture of them. So I'm going to hand it over to you as the class, and I want you to figure it out. Start rearranging them. How many different ways? So you're in an order right now. All right, so let's go to a different order. All right, so there's 2 ways. That would be a 3rd way, right? 4th way, 5th way, 6th way, 7th, 8th way, 9th way. Oh, wow, we're really switching it up. 10th way, 11th way, 12, 13, 14. So my question is how many different ways do you think that I could rearrange them? You think 36? And you think more than 36? Okay. So Emily says more than 36. All right, thank you very much. You can sit down. So how many think 36 ways? Okay, how many think it's more than 36? Because that's what Emily says. Anybody have any other guesses? 42? 720? You think it's that many? You think so? That's because you've been competing on math team. Okay. All right, so let's talk about this and let's see. Okay, let me give you a couple definitions first. Okay, let's talk about the difference between a permutation and a combination. A permutation is an arrangement of a group of objects or people in a certain order. And a combination is an arrangement or selection of objects where the order is not important. So I'm going to tell you the similarities between permutation and combination is we are both going to be talking about ways you can arrange or ways you can choose. But the difference is, and it's going to affect your answer, is whether or not you're putting them in a specific order or not. If you're placing them in a specific position or order, then that would be considered a permutation. If you are not putting them in any order, if I'm just choosing the people or selecting the objects, then that would be a combination. So my question to you is, our example back here, would that be considered a permutation or a combination? It actually is a permutation because you know what I was doing with the 6 people? I was placing them in positions in order. Does that make sense? Like I took a picture of them in one order and then I actually took them, I didn't take them, you took them, and rearranged them in another position or order. Do you understand? Permutation is an arrangement of a group in a certain order. So I was placing them in a certain position to take the picture, right? When someone says, let's line up to take a picture, what does everybody do? Okay, you stand here and you stand here and let's pull our other people here and our short people get in the front. You're placing them in a specific position, right, in order to take the picture. That would be considered a permutation. Now, what if I had the 6 people and I said, I just want to choose 2 out of the 6. I just want to pick 2 out of the 6. That would be considered a combination because I'm not putting those 2 people, I'm just choosing 2, right? I'm not putting them in a specific order. I'm just picking 2 from the 6. That's the difference. And that's where the mathematical side of this is going to be easy. The formula is easy. The way to put it in the calculator is easy. The difficult part of it is choosing, because sometimes it gets a little complicated depending on your opinion of whether it's permutation or combination. Okay? So what you actually did, let's look at factorial first. Yep, this is the definition of a factorial. And it is denoted with the exclamation point. It's the product of all the counting numbers beginning with n and counting backwards to 1. Okay? It's the product of all the counting numbers. What are counting numbers? 1, 2, 3, 4, 5, 6. So basically whole numbers except for 0, right? And you're going to start with that number and you're going to multiply because it says product. And you're going to count backwards all the way to 1. So if I looked at 5 factorial, what would that equal? Oops. What would that mean? If I'm going to start with 5 and I'm going to count backwards, so 5 times 4, because it's a product, we're multiplying, times 3 times 2 times 1. And so 5 factorial is going to be equal to 120. Okay? You actually did 6 factorial back there. Okay? In order to figure out the number of ways we can take those 6 people and rearrange them in that order is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, which is equal to what? Oh, I believe Ryan deserves a piece of candy for that. Okay? And I might give Emily a piece just for, everybody's like, 36, yeah, 36. Don't jump on the boat of 36. I appreciate you saying, I think it might be a little more than 36. Okay? There's actually 720 different ways we could rearrange those 6 people in that order. Does that make sense? And we did that by doing 6 factorial. You're welcome.
Can I get a piece of candy if I show everybody where the button is for the exclamation point?
You know where it's at? All right. So Sky wants to show us. Let's look in our calculator. Sky says there's a way we can do this in our calculator. So Sky, I would like for you to explain. Let's start with 5 factorial. Okay? What would I do to get 5 factorial in our calculators? So you're going to hit 5. And then you're going to go to math. What does PRB stand for? Probability. Okay? And it's the 4th one. It's the exclamation point. And so 5 factorial, when you press enter, you get 120. Okay? Try doing 6 factorial. 6, math, and then arrow over to probability, and choose the 4th option. Sky? There you go. Any questions about factorials? All right, so we're going to actually look at some formulas for permutations. And it looks like this. I do believe this is on your formula sheet. Yes, I do agree. No, P, that is permutation. P stands for permutation. When N is the number of total possibilities, like how many objects or how many people are you working with, and R stands for the rate at which they are chosen. Okay. N is the number of total possibilities, and R is the rate at which they are chosen. So in this case, we did say the people in the back was a permutation, right? Because I was arranging them in a specific order. So my question is what would N be in this case? How many people are we working with? We were working with 6 people. And the rate at which you're choosing them, like if I have 6 people and I'm choosing 2 of the 6, then my rate is 2 because I'm choosing 2. But my question is when I'm rearranging all 6, what's my rate? I'm choosing all 6, right? I'm rearranging all 6. So it's going to be a permutation where I'm working with 6 people and I'm rearranging all 6 people in a specific position. So if we work this out in our formula, it would be 6 factorial divided by 6 minus 6 factorial. And everybody says, well, wouldn't that mean you would be dividing by 0? And we know it's all fun and games until you try to divide by 0, and that just can't happen. But 0 factorial, there's no such thing really as a 0 factorial because when you do a factorial, you only multiply down to 1, right? You never multiply by 0. So really, and if you put it in, somebody try to put in 0 factorial and tell me what it's equal to. It's equal to 1. So really, it's 6 factorial divided by 1, and anything divided by 1 is just 6 factorial. And so doesn't that make sense that when we rearranged and I wanted to know the different possibilities, it would just be 6 factorial, which is equal to how much? 720 ways. Okay? Any questions on that? So let's look at example 2. Let's look at example 2. There are 10 finalists in a figure skating competition, and I want to know how many ways can gold, silver, and bronze medals be awarded. So my question is would this be a permutation or a combination? Why permutation? Right, and I'm taking those 10 people, I'm only choosing 3, right? But I'm placing those 3 in a specific position or order, right? I'm giving 1 the gold medal, I'm giving 1 the silver medal, and I'm giving 1 the bronze medal, okay? So, in this case, what would N be? N would be 10, and your rate would be, I'm choosing how many? 3 to give the top 3 awards to, okay? So if we did our formula, n factorial over n minus r factorial, this would be 10 factorial over 10 minus 3 factorial. Now I want you to understand before you put this in your calculator what this means. What does 10 factorial mean? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whew! What does 7 factorial mean? Times 5 times 4 times 3 times 2 times 1. Can you tell me something about this? 7 over 7 is equal to 1. Cancel, 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 cancel. Everything from 7 and down is going to cancel. So really, what's it going to be equal to? 10 times 9 times 8, which is how much? 720. Now that wasn't just a quinky dink, that it was 720 on 6 factorial and then 720 for this guy right here. But there are 720 different ways that we can take 10 people and award them gold, silver, and bronze. Okay? sometimes with permutations, and this only works with permutations, I like to do blanks. For example, I know that I'm going to have 3 blanks here. Why 3 blanks? I'm going to have a gold medal, a silver medal, and a bronze medal. How many possibilities, and this is based on the fundamental counting principle, and I think you probably covered that in maybe 7th grade, which I know was a really long time ago, but that's okay. Okay. How many different people could I put in the first position? 10. Well, okay, let's just say we award Gabe the gold medal. Yes. Okay. How many different people could I put in the second position? 9. And then how many different people could I put in the bronze? 8. And then that would give you 720 as well. Does that make sense? So sometimes you will see that as well. We'll be using the blanks along with the formula in an activity that we do a little bit later on today. All right, so let's go to our combination formula. Okay, still N is going to be the same thing. It's the total number of possibilities that you're working with, and R is the rate at which they are chosen. Okay, the formula says N factorial divided by N minus R factorial times R factorial. So it is slightly different with the combination. Okay, everybody got this down? So let's look at an example. I'll let you kind of just digest it, and you can paraphrase. You don't have to write word for word. So a group of 7 students working on a project needs to choose 2 students to present the group's project. How many different ways can we choose the 2 students? Do you agree that this would be a combination? Why combination? The order doesn't matter, and you know, you're just choosing 2 students. Does that make sense? We're not placing them in a specific position. We're just choosing 2 out of the 7. Okay, so if we looked at the formula for this, what would N be? 7, and the rate at which we're choosing? We're choosing 2 out of the 7. Okay, so this would be N factorial divided by N minus R. And before you put this in your calculator, let's just look at it by hand first, because I had some people earlier that weren't quite getting it in the calculator. So I like for you to understand how to do it by hand. So not everything, some of it will cancel, but let's look at it. So this will be 7 factorial divided by 7 minus 2 factorial times 2 factorial. So really this would be 7 factorial divided by 5 factorial times 2 factorial. So let's talk about what 7 factorial is. 7 times 6 times 5 times 4 times 3 times 2 times 1. How about what's 5 factorial? 5 times 4 times 3 times 2 times 1. And then we're also going to times by 2 factorial, which would be 2 times 1. Okay, so tell me, what will cancel? 5, 4, 3, 2, 1. So what will I have left? 7 times 6 divided by, so that's really 42 divided by 2, which would be 21. Okay, let's put it in your calculators and see if you can do, and I wouldn't, somebody try to do this part in their calculator. Try it and see what you do. I'd rather put this one in my calculator. We had some issues earlier. what would you have to do? Can you tell them? Where would the parentheses? Okay, around the numerator and the denominator, but especially the y, because there's more than one, okay? So you got to definitely have an extra set of parentheses. Even if you do this one right here, you got to have an extra set of parentheses around the denominator. And it wouldn't hurt for you to have it around the numerator as well. Is everybody able to get it in their calculator and come out with 21? Good. Okay, so let's see. Okay, let me pause and let me come see your calculators. Here we go. Let's look at just a few more examples. So there's 5 total on today's lesson, so we're almost finished with the lesson for today. Okay. How many ways can you arrange 7 shoppers in a line at a checkout counter? How many ways can you arrange 7 shoppers in a line at a checkout counter? Permutation, combination. Why permutation? Well, but I could, what if I wanted to, what if I had 7 runners and I want to pick the top 3? That would still be permutation, okay? It's the difference between permutation and combination is, are you placing them in a specific position or order? So when I have those 7 shoppers in the line at the checkout counter, do I have to place them, this person you check out first, this person you check out second? Am I putting them in a position? Yes, you are. You're putting them, otherwise somebody's got to go first. Because does that make sense when you check it out? Otherwise, there would be a brawl in the grocery store. Okay? I mean, it'd be like everybody like, no, I'm first. Okay? You got to put somebody first, somebody second, somebody third, somebody fourth, somebody fifth, somebody sixth, somebody seventh. Okay? But in this, so it is a permutation because the order is important for permutation. Do you see how I remember that? Order is important. So important, the P, and permutation. Does that make sense? The order is important for a permutation. Okay, the P helps me remember that. So my question for this, if we use the formula, what's my total number? I got 7 people. What's my rate? 7. I'm using all 7, and I'm putting all 7 in that order. So if I did this, this would be n factorial over n minus r factorial. So n factorial is 7 factorial over 7 minus 7. And what is 0 factorial? So this is really just 7 factorial divided by 1, which is just 7 factorial. Okay? And so what would it be? 5,000. 5,040 ways. Okay? Any questions on why it's a permutation and why we're doing 7 with a rate of 7 at a time? Because I'm choosing all 7. Question. Are you good? Okay, so this is where, what did I tell you today? The math is not the hard part, okay? It's tricky to know whether, and we're going to practice, whether it's important or not important. So here's what I'm going to say. If you can take the objects and specifically put them in a specific position or assign them a spot, does that make sense? Like if I'm saying, okay, I got this pencil, and I'm going to place this one here and this one here, and I'm going to put them in a specific order. Pencil, pencil, calculator. Does that make sense? Then that would be considered a permutation. If it's a combination, I'm just choosing or selecting. I'm not placing them anywhere. Okay? I'm not placing them anywhere. I don't know which one's which. All right, so let's just look at more examples and maybe this will help, okay? How many ways can you select 4 of 13 different colored balloons? How many ways can you select 4 of 13 different colored balloons? So Nate, I'm going to choose 4 of the balloons. Am I placing the balloons in a position or am I just choosing them? So would it be a permutation or a combination? It's a combination because I'm just choosing them. Okay, and it doesn't really matter which ones I pick. Okay, I'm just selecting them. Okay, so this would be considered a combination. What goes first? And this is going to be super important in about 3 seconds. 13. Your total number goes first and your rate goes second. And if you don't do it in that order, it will be wrong. Okay? So n factorial divided by n minus r factorial times r factorial. So n factorial would be 13 factorial divided by 13 minus 4 is going to be 9 factorial times 4 factorial. Any questions on that? Now, you can put that in your calculator, but let's think about it by hand. What's going to cancel? Everything from 9 and down. So what will I have on top? 13 times 12 times 11 times 10. We're not going to have anything else because 9 and down cancels out. What else am I going to have on the bottom? All these 9s cancel out. 9 factorial cancels out. So what's left? 4 times 3 times 2 times 1. So that's what you're going to be working out. What will all of that equal? I hear 715. 715? Okay. Make sure you can get that. And if you're going to put it in the calculator like this up top, don't forget you're going to have an extra set of parentheses around the denominator. Okay, so try it and make sure you can get it. Put your calculator. Try it and make sure you can get it. All right, how many want to see a shortcut? All right. So what I would like for you to do is grab your calculators, and I just want you to go over to math and go over to probability. And do you see options 2 and 3? 2 would be your permutation, and 3 would be your combination. So let's just check this one, okay? First things first, you got to put in the 13 first. So clear out your screen, blank screen. I want you to put in 13. Everybody put in 13 first. All I've asked you to do is put in 13. Now I want you to go to math and go over to probability, and we're going to choose choice number 3. And then after that, we're going to do our rate of 4. So in your calculator, you should see 13 NCR 4 and hit enter. What do you get? 715. Okay, you like it? So let's try a couple others. Let's look at example 4. Let's put in, now this time we're going to do, what's our rate? Whoops. So we have 7 is our number. It's a permutation, right? And our rate is 7 at a time. So we're going to do 7, math, probability, choice 2 this time, and 7 at a time. So your n is 7, your rate is 7. Click enter, what do you get? 5,040, which is what we got when we did it by hand. Okay? Let's take a look at this one. This one is combination or permutation. So we're going to do 7 combination with a rate of 2 at a time. So 7 math, probability, combination, 2 at a time. Okay? Any questions? All right. So